So hey everyone, I'm Anastasia Lalamentik. I am a full stack engineer at Kaleido, and today I'll be talking to you about building sustainable supply chains with Hyperledger FireFly and Kaleido. So to start with, we are going to briefly discuss how blockchain could benefit sustainable supply chains. And since you don't do blockchain alone, we will talk about what a multi-party system would look like. We will then discuss some of the challenges frequently encountered when building enterprise-grade blockchain systems and how Hyperledger FireFly takes away a lot of those challenges. Finally, we will walk through an example Web3 use case to highlight the FireFly features you can use to build your system quickly and efficiently. And hopefully there will be some time for questions and answers at the end. So most of us have probably heard about blockchain technology being immutable, transparent, and traceable, which makes it ideal for sustainable supply chain systems. Combined with automation and an event-driven approach, these systems could boost efficiency by speeding up processes that might usually take days or weeks and save time and resources. Instead of waiting for manual paperwork and a bunch of back and forth communications to happen between organizations, with blockchain and multi-party systems, you can just downstream processes that can automatically be triggered when relevant events are detected. Moreover, when organizations work together to communicate and share information on the blockchain, everyone would be more motivated to act responsibly. So let's now take a look at what a multi-party blockchain-backed system would look like. So here we have an example of a private blockchain network consisting of 5 members, each coming in with a system that needs to communicate blockchain-backed data to other members, sometimes publicly and sometimes privately. Each member has their own stack of application, user interface, database, everything that is completely private and isolated from other members. But they all still need to come to an agreement on how assets and data should be modeled so that they can uniformly synchronize data across all their systems. And that part seems pretty simple, right? But what needs to happen in the middle section here? We need stuff like data and document exchange, private messaging, proper delivery and sequencing of events. We need tokenization of assets, identity management, and more. So with enterprise blockchain use cases, the majority of data will actually live off-chain for privacy reasons. When a developer starts building out an enterprise use case, the blockchain part of things may seem simpler. The problem is in the off-chain plumbing, such as being able to sequence events properly, deliver events reliably, tokenize physical assets, and being able to keep a trail of all the movements of the assets, amongst other things that we already touched on earlier. So all that takes away focus from actually developing the business logic. Ideally, the job should just consist of modeling the assets and data model, defining the process orchestration, turning smart contracts to simple to use APIs, and then finally deploying the use case. Fortunately for us, there's currently an open source platform in active development that strives to take away all those off-chain complexities that we mentioned. So let's take a closer look at Hyperledger FireFly. So in FireFly, you can easily mint, transfer, and burn fungible and non-fungible tokens. You can broadcast data, send other members private messages that are hashed and pinned to the blockchain. You can subscribe to events in the network through WebSockets and webhooks. FireFly provides deterministic ordering between all parties and identity assurance for data flows. So when you use FireFly, you can really write 80% less code and just focus on your core business logic instead of trying to reinvent the wheel that tends to be really complex. So with Web3 applications, they're set apart by on-chain logic or smart contracts, right? So it is crucial for each party in the system to be able to interact with them correctly. Smart contract developers can utilize FireFly to generate RESTful API endpoints that are familiar to traditional backend developers that are building the core core application logic of the system. So with all that said, let's focus on an example use case in sustainable fashion. So we have players in the network, such as fashion brands, con suppliers, and an ethical sourcing association, who is a trusted entity that researches con suppliers and rates them based on their practices. So everyone in this consortium is incentivized to act responsibly. Cotton suppliers want to strike deals with fashion brands. They want to maintain a reputable rating from the Ethical Sourcing Association. So they really have to make sure that they do the best that they can to be environmentally friendly and sustainable. Fashion brands want to work with the best cotton suppliers because that also affects the general public's view of their brand. And with everything being so traceable, they can link a clothing item back to a specific batch of cotton harvest and maybe even provide consumers with a platform where they can check where their shirt came from. And then the Ethical Sourcing Association can award certifications in the form of NFTs to sustainable cotton suppliers. They can award fungible tokens to members who contribute meaningful data for their research, which can maybe be spent to vote on various industry-related decisions within the network. And yeah, so fashion brands can trust cotton suppliers' claims about being GM-free and child labor-free, since there are on-chain records of their certifications minted by the Ethical Sourcing Association. So with that use case in mind, let's get started with the demo. I'll actually switch to sharing my whole screen here. Okay, so here's what we're going to run. I have the FireFly CLI set up on my computer. I'm going to spin up a FireFly stack consisting of 4 members. Those members that we've mentioned in the sustainable fashion use case. So let's get started with that. So I'm going to just name the stack demo. I'm going to initialize 4 members. I'm going to have the Ethical Sourcing Association for org 0. I'm going to have fashion brand A for node 1, fashion brand B, and lastly, I'll have the cotton supplier. So now we have that set up, and I'm going to start the stack. So as we're waiting for this, I want to talk a little bit about what's inside of a FireFly supernode. So we're spinning up a total of 4 FireFly supernodes right now. And each one has all these components in this picture. So there's FireFly core, which contains a database, data exchange, a blockchain connector, tokens connector, shared storage. I didn't turn on the metrics for this stack, so we can ignore that for now. And then you also get a really nice UI to track all the events and transactions that go through the system. And you also have a sandbox for each member where you can try out all the different APIs that FireFly has made available to you. So just to explain how I'm going to go about this demo, I have 4 different browser windows that are color coded. So for the green one, I'm going to, whenever I go to this green window, I'm going to act as the Ethical Sourcing Association. The red one is fashion brand A. The pink one is fashion brand B. And lastly, the blue one will be for the cotton supplier. So let's check on the status of this right now. It's still going. I'm going to show what's actually happening in the background in Docker. So in the slides, so it uses Docker Compose to run all of the components, right? And you can see it here. So we have 4 members, member 0, 1, 2, 3, and each member gets their own tokens, container, FireFly core, ETH Connect. Each one gets their own sandbox, IPFS, which is the shared storage, data exchange. Yeah, so all that good stuff is there. Let's see. So since we're still waiting for that, I also want to show the documentation for Hyperledger FireFly. And this is where you can read more in detail about the things that I just talked about and the things I'm going to talk about after the stack is stood up. And you have this getting started instructions here where you can pretty much do what I'm doing right now and try out the demo on your own, maybe for your own use, the use case that you have in mind. So let's see here. Still going. Hopefully it won't take too long. Let's see what else I can talk about. Do you have anything to add, Nick, for now, since we're still waiting for this spin up?
No, not off the top of my head. Aaron asked a great question in the chat, sort of talking about, does every single participant inside of this ecosystem kind of need their own sovereign stack? There are scenarios where, we see, different classes of participants, right? Where, for example, you may have the core stakeholders that truly do need to own and operate the nodes and participate in consensus. Then there may be sort of class B, right? Where people want direct access into the network, but don't necessarily have the technical acumen or the budget to stand up those resources. So sometimes what we see in those scenarios is we see what we call a proxy operator model, or sort of this benevolent dictator model, where the founder or one of the core stakeholders in the network will help stand up resources on your behalf, and then you can just sort of create your own OAuth tier, right, to delegate login to that. The third option is just simply to kind of handle end user access solely at the application tier, right, and kind of code that directly into your application logic to determine who can see what, who can do what. We're not going to get into it on this demo, but there's some really, really nifty stuff available in Kaleido around delegated access and around role-based access control too. So the good news is that there's an answer for whatever level of access, sort of an end user or a participant needs inside of the system, but don't necessarily have to stand up your, own fully fledged FireFly stack.
Cool. Yeah, thanks for the awesome explanation, Nick. So looks like the FireFly stack is ready. So I'm gonna continue with my demo right now. So yeah, just a brief overview of the FireFly UI. As I've discussed before, here are all the pieces that make up the FireFly core. You have WebSockets, webhooks you can subscribe to listen for events. And then you can also see who's in your network. So I am the Ethical Sourcing Association, and I can see that there are 3 other members in my network. I can look at their Ethereum address, which I'm going to use later on. And then I can look at the nodes, identities, namespaces. And there's also a really neat Swagger UI where you can try out the APIs that have been made public by FireFly. And all these APIs pretty much is what the FireFly UI and the sandbox is using in the background. So yeah, so with that being said, let's actually move on to the use case So I am going to first show messages in FireFly where you can broadcast and send private messages to different members in the network. So for broadcast message and taking the specific use case that we have in mind, I am acting as the Ethical Sourcing Association, and I had just finished researching new ways to recycle cotton, and I want to publish this information to the members in my network. And I'm going to tag this message with new research, and topic could be recycling. So just a quick note on tags and topics. Tags are a good way for different members in the system to be able to detect events and decide what logic they want to respond with when they detect a certain tag. So for example, when a fashion brand receives a tag, an event that says new research, they can maybe automate some processes where this document gets sent directly to their research team. And I don't know, maybe they want to post something on their social media about it, something new that's exciting. And then topic is a good way for, it's a way for FireFly to sequence events correctly. So you don't want things to go out of order in the system, because things can go wrong really quickly if you process things in the wrong order, right? So yeah, that's how we utilize topic for event ordering. So let's broadcast this message that has a file attached to it. And now I'm going to open up the fashion brand FireFly UI, and I can see under off-chain messages that there's a broadcast event with the tag new research, with the topics recycling, and I can download that and see the document. And that's the same case for all the rest of the two members here. They can also see this information. Let me refresh these pages. Great. Yeah, but they all pretty much received the events the same way fashion brand A did. You can see the timeline, the activity timeline. There's a message confirmed with the same information for cotton supplier 1. So now that I've showcased broadcast message, let's actually move on to private messages. And before I send a private message, I want to define a data type. So for this use case, I am going to act as the cotton supplier. And let's say that I've signed contracts with fashion brand A, where I will report any new harvest that I get. And I want to first tell the network what that data is going to look like. So I have a simple schema here. I'm going to use to describe what a cotton harvest message would look like. So you have the ID, the unique identifier for the cotton yield. You have the type of cotton. There's maybe Pima cotton, upland, Egyptian. There's the number of bales of cotton, and the expected type is integer. And then their source could be the information about where the cotton was harvested. So I'm gonna specify this data type and broadcast that to the network. So now, as the Ethical Sourcing Association, they can see that a new data type has been published. And same thing with the other members in the network. So now I'm ready to send a private message. I just got my first harvest of the season, so I'm going to, maybe it's Pima cotton and sourced in Lubbock, Texas. That's probably not real, but let's just go with that example. So we have this data type that we've selected, and I want to showcase how this, how the data type being selected here can prevent can validate data against a schema that was defined before. So let's say I was careless, and instead of putting the bales field as a number, I'm putting it as a string. And then again, I'm working with fashion brand A, so I'm going to send this information to them. And then I'm also working with the Ethical Sourcing Association to report my harvest to make sure that, so that they can validate that it's ethical. And this topic is about Pima cotton. And yeah, and let's say that I don't have anything to do with fashion brand B right now, so I don't want them to know anything about this harvest. It needs to be kept private between me and the ESA and the fashion brand that I'm working with. So I'm going to try to send this message, and as you can see here, I get an error. And the error message says that data does not conform to the JSON schema of data type cotton yield. And that's because I did not specify the right type for the bales field. So let's actually fix that and just assign that to 3 and run it. So that's successful. And as the Ethical Sourcing Association, you get an event with this tag, new harvest, and in your application, you can start triggering some processes on your side. Like you can start telling people to do research on this new information, and you can also see the specifics of the message under off-chain messages, private, and you can see the exact message that I sent from the cotton supplier sandbox. And to show that it's completely private, I can go to fashion brand B, and they did receive a blockchain event, but since they're not part of the group where that message was sent, they don't actually have access to the private message itself. So just a comparison of what the Ethical Sourcing Association sees versus what fashion brand B sees. They don't get that information, and even though they do get the blockchain badge pin, they can't decode the hash either, because they don't know who all is involved in the group message, and they don't know they have to know what the message is. So that's how private messages work. And that actually concludes the messages portion for this FireFly demo. So moving on to tokens, I'm going to go back and act as the, just before I forget, since I'm for fashion brand A, they also get notified that there's new harvest coming. There's new harvest and it's coming to their warehouse soon. So within their system, they can start planning for producing like a few thousand shirts just from the cotton that they're expecting to receive. They can plan to clear their warehouse and do all that good stuff without having to rely on too many emails or wait too long for the information to get back to them. Okay, so now let's move on to tokens. And the use case that we discussed before is awarding cotton suppliers with tokenized certifications. So I'm the Ethical Sourcing Association here, and I want to create a token pool for GM-free awards. So I'm gonna choose the non-fungible type, and as the token, as the cotton supplier here, I can go to the tokens dashboard and see that a new token pool has been created, although there's currently no tokens right now. And now that that's done, I want to mint, I as the Ethical Sourcing Association want to mint a token to award and attach some data to it, which could be the GM-free certificate for Cotton Supplier 1. So I'm going to mint that token, and I can send a tag, attach a tag to the message, which says new award, and the topic could be GM-free. And now everyone gets that message that there's a new award that was minted by the Ethical Sourcing Association. And you can also now see that show up in the tokens transactions. There's a message ID attached to the mint event here, which is pretty much the same certificate that I've shown before. So that's how you attach a piece of data to a token mint. And then since we haven't yet, since we want to have full control of these tokens as the Ethical Sourcing Association, maybe sometime in the future, they realize that Con Supplier 1 wasn't being completely honest about being GM free, and they want to burn that token. They can also do that and send a message with it. Free. And it could be award revoked, GM free. And then we can see that the token here is burned. And from a fashion brand perspective, they can read this, receive an event and read this tag and choose to, maybe not work with the cotton supplier anymore. And then you can also, as the Ethical Sourcing Association, create a pool of fungible tokens to award different members in the network for contributing useful data. ESA coins. You can create the pool first and then mint maybe 1,000 tokens or more. And lastly, you can transfer that to other people in the network. So Con Supplier 1 submitted some data to me earlier in the week. So I want to reward 5 tokens to them. And okay, interesting. Let me try that one more time. Let's just award 1. Okay. I think it's being a little slow, but yeah, you get the idea. You can use fungible tokens to and transfer, burn them, and kind of come up with your own creative use case as to how you want to utilize these. So yeah, so that's tokens on FireFly. You can definitely upload your own custom token contract, but I'm just using what's already built in. So I didn't have to put anything here in the contract address, but you can definitely do that if you want to. So moving on to the exciting stuff, I'm going to show custom contracts on FireFly. So I have a an example voting contract here that I simplified a little bit. And for this use case, we'll just go with the Ethical Sourcing Association having a voting event for which research topic they should pursue next. So here I just hard coded some options. So different members in the network can choose to vote for more research in Egyptian cotton or Pima cotton or upland cotton. And to walk through a little bit of this custom contract, I have a function that gives the right to vote. So this would be the Ethical Sourcing Association that can give the right to vote. There's the voting logic here where you can only vote once, and you can only vote if you have been given the right to vote. And then there's also some functions that calculate the current winners of the vote, the voting. And then I have some events here that I'm going to listen to in FireFly. So anytime someone voted, I might want to get notified about it. Anytime I've been given the right to vote, I also want to get notified about it. So yeah, this is just a simple smart contract that I'm going to deploy to FireFly here. So first, I'm going to compile the smart contract. Which I've done before, but I'm just going to do it again. And then I want to deploy it. So ff deploy Ethereum demo is my stack. And this should give me an address where that smart contract lives. So the next thing I want to do is to actually define the contract interface. So I'm going to select ABI here, Solidity Application Binary Interface, and I'm going to format this compiled JSON. And here's the ABI property where there's an array of different inputs. I'm going to copy that over here and name this vote research topic version 1.0. So yep, so now the contract interface has been broadcasted to the whole network. Everyone's aware of this now, and the next step would be to register the contract API. I'm going to paste the address that I have here. And okay, so now we have the contract API, which you have its own separate Swagger for, which is really great. And as you can see here, you can invoke the smart contract and call different functions just through RESTful APIs. And then you can also register contract listeners. If you remember, I've showed you the 3 events in the smart contract, and let's just say that I am going to subscribe to all of them. And maybe as another member that's not the Ethical Sourcing Association, I also want to subscribe to this event, given right to vote, just in case, so that I know when I've been given the right to vote. So there's that. Cool. So let's now start giving the right to vote to other members in the network. You can go back to the network organizations here because we're going to need their Ethereum address. So I'm going to copy this for fashion brand A, and I'm going to, as the Ethical Sourcing Association, give them the right to vote, and also Cotton Supplier 1 the right to vote. maybe I don't want to give Fashion Brand B the right to vote just because they haven't contributed as much to the ecosystem. So I'm just gonna not worry about them right now. And great. So as you can see in the cotton supplier FireFly UI, before we subscribe to the blockchain event for being given the right to vote. And here's where you can see some data about it. The chairperson is the Ethical Sourcing Association, and they've given me the right to vote. That's my Ethereum address as the cotton supplier. So now that I have that power, I am going to cast a vote. And in my smart contract, I'm taking the index of the options. So let's go back and see what the options are. Egyptian, Pima, and Upland. Okay, so I'm going to vote for Pima, and that's index 1. So I'm going to submit that. And the transaction has been accepted. And on the Ethical Sourcing Association side, if they go back to their blockchain dashboard, they detected this event that a vote has come through from this address, and they voted for Pima. And so now let's actually submit another. Oh, let's say that the cotton supplier changes their mind and tries to submit another value for their vote. The smart contract does not allow it because they have already voted. So it's pretty cool. And then what's the other organization here? If Fashion Brand B, who hasn't been given the right to vote, tries to vote, they also won't be able to because the smart contract will prevent it. Here you can see that the call failed, has no right to vote. And let's say that no one else submits a vote and it's already time to determine the results. The Ethical Sourcing Association can try to get the winner name. And since they subscribe to the event, they can see here that the winner is Pima, and they won by 1, or they got a total vote of 1 because no one else really voted. But yeah, that's all I have for the contracts portion and for this demo. Just to go back to my slides. I mean, you've seen me set up the whole thing from scratch. And so it's really quick and easy for anyone to get started with or without prior Web3 experience. It can do a lot of things. I've highlighted various use cases for just an example, sustainable fashion use case. You've seen that a lot of the tools that we use are familiar: TypeScript, JavaScript, WebSockets, Docker, CLI, the CLI. There's nothing too crazy there. So, and it also lets you run an entire developer stack offline, right? You don't have to spend any money just to test your blockchain system. So yeah, give it a try. And I guess the next question is, if you've tested your system really well and you're confident about launching it and going live, how do you go to production? So everything I just did, Kaleido offers spinning up super nodes on there. So you can create a network with the same members that I created. You can spin up the FireFly UI, the sandbox, the Swagger, everything I had just shown you through Kaleido, which is great. And they're live nodes, they're on the cloud, and you can connect to them straight from your applications. And then, yeah, so that's that's a really nice and easy option for you if you want to go to production with this. And yeah, if you're interested in Firefly, definitely join the conversation on Discord. There's a lot of good discussions there. If you have certain really great ideas, feel free to share them there as well. If you are curious about the inner workings of the more complex components of Firefly, make sure you look through the Hyperledger GitHub and search for Firefly repos. Submit issues if you run across them, and if you do choose to try out building your application through Firefly, feel free to use Discord to get some support and some help. And yeah, that's all I have for today. Thank you so much for listening in, and I'll pass it back to Nick. Oh, I see a lot of chat.
Tons of great questions in the chat. Thanks, Anastasia. That was a wonderful job right there. So yeah, I want to kind of sort of stress on one thing Anastasia said at the end. There's a really logical migration path here in the sense of, you can do all of this very, very easily, locally on your MacBook, on your Linux machine, stand up these containers, start testing your smart contracts, and start testing those other pieces too that are pretty critical to every single use case, regardless of your industry. And those would be sort of private messaging, right? There's always private data somewhere inside of an ecosystem, and then the need and requirement to dynamically ingest events into your own back office systems, right? And the cool thing about events, we've talked about this a lot in the past, but you can write your own triggers, you can write your own serverless functions and react to these events based on your business requirements, right? So I get event type A, we sort of trigger this downstream process. I get event type B, we just park it in our local database. And events also make your application tier incredibly, incredibly efficient. You're never going into the blockchain. So that's really the thesis about Firefly. It's this super, super powerful orchestration layer that's sitting above the blockchain, but giving you a really consumable, clean API to handle all those things Anastasia talked about: publicly broadcasted messages, privately encrypted messages, token interfaces, custom smart contracts, events, on and so forth. So yeah, it's a really easy sort of navigation path for you to just start locally, right? And then all you're going to change in your application tier, instead of pointing to localhost, you're going to be pointing to a proper URL that's secured with authentication credentials on Kaleido. So very, very elegant transition here. Kevin put some great resources into the chat. If you guys have any questions, I'll put my email in the chat. You're welcome to reach out to me directly. If you have platform questions about Kaleido, you can contact us directly on the website or send us a ticket to support@kaleido.io. And it's free to try Kaleido too, right? There is no pay barrier. Don't have to put a credit card in, just 30 seconds, create an account. And if you don't want to do this stuff locally, just click a couple buttons in the console and you'll have your sandboxes and super nodes running on Kaleido. So hopefully this was a useful sort of demonstration about the art of the possible, focused on a supply chain use case, but obviously very extensible to financial services, healthcare, insurance, retail and entertainment, you name it. So I'll just sort of echo Anastasia's statement. Really appreciate everyone showing up today. Please join the open source Discord. Please create a Kaleido account and reach out to us. And we'd love to talk more about your use cases and answer any questions that you guys have. So just another big thank you from me, and I hope everyone has a great day. This is recorded. You'll get the recording in probably 24 hours, and it will maybe 48 hours, and it'll also go on our YouTube page as well. So yeah, that's it for me. Thanks again to Anastasia, and thanks for all the folks that asked great questions in the chat.
Thanks, everybody. Take care.